problem 11 in section 2.1. So we're given this function f that is in this way. Then we want to say which zero this f is converging to, which zero of f this bisection method is converging to when we apply it to the following four intervals. Okay, so you can do this either by coding to see that, or for this question, we actually can do this just by hand, pretty easy. So how are we going to do this? So first of all, by looking at this function f here, we know what are the roots, right? Exactly what are the roots. So it should be -2, -1, 0, 1, 2. So these are the four roots. And we can also decide the sign of the function over the intervals, because starting from, so we arrange those roots on the line. So starting from the very right one, we're going to have positive, and then we're going to have a negative in between. So this is the trick. You really can design sign. You can always start from upper right, and once you see a root, you're going to pass it. Well, it depends on the multiplicity. If you see these are all multiplicity of 1, and this has a multiple of 3, as long as it's odd, then you will pass it. Otherwise, you will not pass it. For example, if you have x squared here, then you cannot pass the x. You're going to go back. Okay, so if you have an even root, you should go back. Otherwise, you just pass through it. This is how you're going to decide the sign. This will be positive. If the line is above the curve is above the line, then it's positive. Otherwise, it's negative. So this decides the sign. Once the signs are decided, we can see what will be the result of the bisection method. For example, in the first case, we look at the interval -3 to 2.5. So 2.5 somewhere here, which is positive. -3 some point here, which the function value is negative. That's why we have this. Now, once we have that, by applying the bisection method, we're going to find the middle point right in the middle between these 2 points. And that is -0.25, which is somewhere here. So the value is negative. So we're going to pair this point with this 2.5 here, because these two have different signs. So originally it's this, and we half it, and I'm going to choose this interval. Okay, so this interval is -0.25 and 2.5. Then we're going to apply the bisection again, which is to find the middle point of these two. That is 1.375. So that's somewhere here, maybe here. And you have 2.5 here. So now you can see that when you narrow down to this, there is only one root left, which is 2. So in this case, you will just get 2. Okay, so the bisection method is going to converge to 2 if you're using this interval. Okay, you can try this by applying your code, but that's the answer you can get. So the same for all the others. I'm just going to list the result, but you can go over exact same process to determine the root. So the second one, I think I'm going to stop. The bisection is going to stop at x equal to -2, and the C you're going to stop at x equal to 1, and for the last case, your bisection is going to convert to 1.